Your penicillin was made available to mankind during the biggest of wars, but it is unable to serve anything but peaceful purposes. It cannot kill a mouse, though it can heal a man. Prior to his speech at the banquet of the 1945 Nobel Prize in Physiology or Medicine, Alexander Fleming was addressed by Swedish scientist Axel Hugo Theodor Thorell. Fleming was praised for his discovery of penicillin and willingness to share his discovery with the world. So, why was the discovery of penicillin by Alexander Fleming in 1928 so incredible, and how did it catapult research into the discovery of new drugs and help battle once untreatable diseases? To start, we need to understand where infectious disease comes from. Almost all infectious disease comes from microorganisms, incredibly small organisms that have lived on Earth for millions of years. These organisms are generally harmless, but some can cause infection and illness. Treating these hazardous microorganisms involves the synthesis of chemicals or extraction of naturally occurring compounds. Medicines that treat harmful microorganisms are known as antimicrobials and can be categorized into four distinct groups. These groups are antibacterials used to treat bacteria, antivirals used to treat viruses, antifungals used to treat fungi, and antiparasitics used to treat parasites. It is thanks to antimicrobials that many common procedures today are possible, such as the sterilization of operating rooms, treatment of diseases, or organ transplantation, which would otherwise be impossible. Unfortunately, as microbes are living organisms, they have the capacity and capability to evolve through natural selection. Subsequently, microorganisms can develop resistance to antimicrobials. This phenomenon is known as antimicrobial resistance, where microbes develop resistance to drugs, causing them to no longer be effective for treatment. The severity of this problem has been addressed by the World Health Organization, which has categorized AMR as one of the top global public health and development threats. So, what can we do about AMR? There are many factors contributing to antimicrobial resistance, including the overuse of antimicrobials in humans, as well as in the agricultural space with plants and animals. The simplest way to limit AMR is to limit sickness. Simple steps that lead towards illness prevention include vaccination, frequent hand washing, keeping homes, pets, and personal spaces clean, and preventing infection in the first place by cleaning cuts and wounds. For those that do get sick, it is important to fully follow through on every antibiotic prescription. This ensures that every infectious microbe is killed, eliminating the chance for resistance to be shared with other microbes. Scientists are doing their best to stay one step ahead of the microorganisms that are developing resistance to our drugs, including the development of new drugs and implementation of new techniques and strategies. Almost a century after Alexander Fleming discovered penicillin, antibiotics are saving millions of lives every year, so for now, we should be optimistic.